Hai, Assalamualaikum. Selamat malam, salam sejahtera. So, our class tonight discuss about this tutorial 6, circular motion. So, saya boleh dengar suara saya clear? Boleh tolong respon dulu? Okay. Jadi, boleh dengar suara saya dulu? Boleh respon dulu? Okay, Audrey cakap macam tidak jelas. Macam mana yang lain? Okay, so kalau sudah okay, so we continue tutorial 6 circular motion. Untuk yang sebelum ni kita dah tengok, okay, saya share screen dulu. Okay, sebelum tu saya minta maaf, sepatutnya tadi kelas 8.30 because of saya berada di luar Labuan sekarang ni. Jadi kena set up dulu alat dan sebagainya. So kita agak terlewat sedikit, tapi tidak apa. Dan besok pun hari Sabtu tak ada kelas. Kamu pun berada di college. Jadi sebelum itu juga ya, untuk pengetahuan minggu depan ataupun minggu depan kita akan ada second ujian yang kedua, chapter 5, nanti chapter 7, right? So malam ni kita akan settle untuk chapter 6 and the next mungkin besok ataupun lusa kita akan bincang mengenai chapter 7, right? Maksudnya sebelum kamu pergi pada ujian itu, so kita kena settle dulu lah untuk chapter 6 and chapter 7. Chapter 5 sudah habis. Okay, so start tutorial 6. So for the tutorial 6 you can refer to the tutorial at the Google Classroom. Di sana sudah ada ya. Tutorial 6, the tutorial 6 is circular motion. So first we start about the objective question. Look at the question number 1. Right? Question number 1. Right. For an object to move in a uniform circular motion, it must move with, answer given by the question is A, constant speed, constant acceleration, right, constant direction, and constant momentum. So meaning here, object move in a uniform circular motion. So we have already discussed, if you have the object moving in the circular parts, the first is you must have the speed, right? The speed here, right? Sorry, this is a direction of the speed, right? Right. And the direction of the speed here is always tangent, or we call this as tangent, right? And we have the constant speed, but the direction of the speed here always change, depends the position of the object, right? So meaning here we have a constant here is constant speed, okay? Lajunya yang sama constant, but the value of the velocity. Value of the velocity is always change because change of direction. So meaning here, the speed for the object in the circular part is always constant, right? But the velocity, so the velocity here is referred to the, we have the change of direction, change of direction of the objects. So meaning here, if the change of the direction produce acceleration A, right? Produce acceleration A. So if the change of the direction, we have produce acceleration, or we call it centripetal acceleration, or AC. So here we have a AC. But if you look at the question number 1, asks you for the object in a uniform circular motion, meaning here we have a constant speed. So if you look at the answer number A, number B, and number C, or D, here we can, the answer here is a constant speed. Constant speed, but change of direction produce acceleration A, or we call it centripetal acceleration. Actually, if you continue, if you have a centripetal acceleration, AC, you can relate to the centripetal force, because if you have a centripetal acceleration, second Newton law, you can relate between the acceleration AC and the centripetal force FC. This is a second Newton law. All right, this is number 1. The answer is A. So continue to number B. Right, number 2. Sorry. Okay. A particle move with a constant speed on horizontal circle. As we already discussed, constant speed for the circular part here, in the horizontal circle, which the following quantity is a 0. Okay, which the following quantity is a 0. So meaning here, we have speed, but the speed change of direction produce acceleration AC, and you can relate to the centripetal force FC. But the question asks you, what is the, okay, ada soalan, sorry, Dominic. Okay, Dominic bom tadi, dia tulis, lepas tu dia padam balik ke? Yeah, Dominic asks, why for the question number 1, why not the answer is, why the answer is A, So saya bagi tahu tadi, the answer is A. Why the answer is not the B? Yes. Jadi kat sini sebenarnya setengah-setengah buku ataupun dalam setengah nota tu, konsep speed, the speed and the velocity. So as you know, velocity, you can use the speed and velocity because the symbol is we have the same symbol, or use the same symbol V. But if you relate the speed V here for the speed, meaning we have a scalar quantity. Scalar quantity meaning we have only the magnitude, right? The magnitude. So meaning here, no need consider the direction. But if you relate the V here to the velocity, meaning here you must consider because velocity is a vector quantity, meaning you must consider the magnitude and direction. So now here, because in the circular motion, we have a constant speed. We have the constant speed, but actually V here is not change. The change here is a direction. So if the direction change, meaning here you can produce the acceleration, or we have a centripetal acceleration. That's why, Dominic, the answer is not B, the answer is A. We have a constant speed, but not constant velocity, because we have change of velocity because of change of direction. Okay, that's why the answer is A. So saya nombor 1 ni macam bagus soalan dia. Dia jawapan senang saja, tapi ya dia banyak menjelaskan perbezaan di antara the speed and velocity for the circular motion. So I think we continue to the question number 2. Okay, question number 2. question number 2 tadi kita dah tengok, or you can refer to the your own dia kamu punya soalan tutorial particle move with a constant speed in horizontal circle with the following quantity is equal to 0, right? Is equal to 0. So the answer is angular velocity, angular acceleration, and centripetal acceleration, right? And the resultant force, right? So because the constant speed but change direction, meaning we have a centripetal acceleration. So here, because the centripetal acceleration here, okay, because sentiasa berlaku perubahan V so mesti ada perubahan acceleration, right? So meaning here, if you look at the question number 2C, the answer number C is jawapannya salah kan? Because centripetal acceleration is not equal to 0, right? So resultant force, because of we have a centripetal acceleration, meaning we have a net force or centripetal force because F is equal to MAC, subscript C. So here we have a FC, F subscript AC. Actually, we have a F is equal to MA. So F is equal to MA here for the second Newton law. This is referred to the linear motion. So now I write we have a F subscript C refer to the circular motion. Here 6 cm. That's why is F subscript C is equal to M subscript AC. Okay. So the answer this is a wrong answer. Okay, now we have only A and B. So for the look at the number B, angular acceleration. So angular acceleration. So here we have a constant speed. The constant speed here is referred because we have a omega. Okay, so yang ni sebenarnya kita akan belajar dalam chapter 7 rotational motion. Cuma dalam ni kamu akan belajar mengenai omega. Omega is angular frequency. So kita ada alpha is angular acceleration. Okay. Sebenarnya untuk partikel yang bergerak dalam horizontal circle, untuk horizontal circle constant speed, dia merujuk kepada nilai ataupun kuantiti yang merujuk kepada is equal to 0. The answer is the omega angular frequency or alpha ni is equal to alpha is equal to 0 and omega is a constant. Jadi sebenarnya kat sini because saya untuk chapter ni nanti kalau kita dah masuk chapter 7 nanti dia lebih jelas because first, kalau kita dalam linear motion, saya buat LM, linear motion. Lepas tu kita ada circular motion. So kalau dalam linear motion, we have a velocity. Kalau circular motion or rotational motion, this is chapter 7, RM, we have a omega, okay, angular velocity. Kalau acceleration for linear motion, we have a alpha. This is a angular acceleration. Okay. Displacement S for the linear motion. In the circular motion or rotational motion, displacement is referred to the theta. Theta. So this is how you can relate linear motion to the rotational motion or circular motion. So now, for the question number 2, okay, if the V constant, acceleration is equal to 0. So the same, if the omega is angular frequency or angular velocity is equal to 0, omega is constant, right? And alpha is also equal to 0. So here you can refer to the linear motion and circular motions. Dia cuma berbeza dari segi dia punya simbol dan bagaimana diterangkan. This is a linear motion for the V, but omega for the circular motion, right? Okay, so the answer is number 2 is B, angular acceleration. Okay, so we continue to the number 3. Okay, saya kecilkan sedikit kat sini ya. Okay, question number 3. Alright. Saya harap biasa ya kalau ada soalan atau ada apa-apa pertanyaan boleh tak dekat ruangan chat tu ya. Okay, so continue to the number 3 ya. Question number 3. Okay, question number 3. Okay. Di sini macam tidak nampak tapi saya rasa boleh mungkin apa ni objek ke apa. Okay, let's say object moves in horizontal circle with a constant speed v1. Okay, so kita ada satu jasad sedang bergerak dalam satu katalah gerakan putaran the velocity of the object is a v. It's a v1 this is let's say it's a v tangent v1. When the same mass move in the same circular path, okay, katalah jasad kedua, the second mass, so I use a black color here. The second mass we have a speed v2. So we have the speed v2, but the mass we have a same mass, meaning m1 is equal to m2. But the new centripetal force is half of the first. So meaning here for the object m, because in the circular motion, the centripetal force, equation for centripetal force Fs, Fc is equal to mv square divided by r. So for the first object, okay, for the first object, I use a m here. This is for the object m1 because mass 1, and the v1 here square, but the same circular path, meaning we have the radius the same value. But for the second mass, we have the same mass. The second mass here, black color here, we have half of centripetal force is half of the first, meaning here we have the centripetal force for the F1 half of the F1. So meaning here, kalau kita lukis kat sini for the F1 here we have M1 V1 square divided by R, okay, divided by 2. This is equal to F2, centripetal force for the second object, right? So here, if you look at the equation, this is macam persamaan matematik yang kita ada kat sini, right? Persamaan yang kita ada kat sini. So this is equal to for the F1, right? This is for the F1. So now the question asks you to calculate the ratio or the V2 divided by V1, right? V2 divided by V1. So kalau kita tengok kat sini, kita boleh buat perbandingan kat sini So, saya padam dulu sini. Right, saya padam dulu sini sini. So we have a M1 V1 square for the first object, right? And the second object we have the same mass, also M, so M1, but we have a V1, this is V2 square divided by R, the same R, and the ratio, the force for the F1 is equal to 2 times, right? For the 2 times or divided by F2, right? No, F1 is equal to F2. No, because this is the force is half of the first. So sorry. So, F here is for the F2. This is F2. If you relate here, F2 is equal to F half of F1, right? half on F1. So here we can use, this is mathematics, V1 and V2, right? So kalau kamu guna persamaan matematik kat sini, okay, kalau kita guna perbandingan kat sini, because F2 is equal to half of the centripetal F1 here. So we have kita boleh cancel M plus 1 is square. So we have a V2 divided by V1 is equal to square root 2. Ini kamu boleh kira secara matematik kat sini, right? So V2 divided by 1 is equal to 1 over square root 2. This is equal to 0.7. The answer is B. Right? So continue to the number 4. Okay, number 4 here. So number 4. So number 4 is a calculation question. So if you look at the question here, okay. Frequency and angular velocity of a clock second needle is okay. Kalau kita tengok kat sini, okay, kalau kita tengok this is kata jam dinding, so we have needle, biasanya jarum saat tu, kasi yang bergerak tu, jarum saat tu menunjukkan okay, masa, this is 12, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is so meaning here from the 1, if the needle of the clock start moving from the 1 o'clock, okay, and back to the initial position 1, this is one complete oscillation, one complete circle here. So now, the frequency and angular velocity. So what is the frequency and angular velocity? So if you look at the equation or the formula, the first frequency, definition of the frequency or F is a number of complete circle in 1 second. Okay, berapakah bilangan putaran lengkap dalam masa 1 saat? This is a frequency. So here, because complete oscillation here, the complete oscillation here is, let's say, the one complete oscillation. So the frequency is 1 over period t or time t. Now this is the equation how you can relate frequency and the period t, right? And the angular velocity is omega, right? Omega, but for the linear velocity is a v, velocity v, but for the circular motion, the v here we can use angular velocity. So what is the equation for the angular velocity? So angular velocity, so you can use the distance here is theta divided by time t, or you can use omega, or angular velocity is also 2 pi f because of 2 pi, because f is equal to 1 over t, or you can use omega is also 2 pi over t, right? So meaning here, you can use the equation for the omega here. We have a theta over t, we have a 2 pi f, or we have a 2 pi divided by the period t. So now the question asks you to calculate the first is a frequency. So one complete circle for the frequency here, this is a second needle. So meaning one complete here, this is a 60 second. The period is a 60 second. The t here, one complete, satu putaran lengkap jarum saat itu menunjukkan 60, okay, 60 saat kan? Okay, satu putaran lengkap. This is equal to 1 minute. So this is the frequency, right? And 1 over 60 is equal to 1.67 exponent minus 2 hertz. This is equal to 1.67 exponent minus 2 hertz, right? Okay, and for the angular velocity, because the angular velocity equation, omega is equal to 2 pi f, and the 2 pi is constant, and the frequency here is 1 over 60, 1 over 60 or 1.67 exponent minus hertz. So you can use the calculator here. The omega here is equal to, because the answer is combination between frequency and the angular velocity. Here you can use the calculator. You can compare the answer given is a 0.105. The unit is a angular velocity radian per second. Okay, the answer, question number 4, the answer is A. Right, class. Continue to the number 5. Okay, the last question for the objective question here. Right. Okay. So what is the question number 5? Assume an object is moving at constant velocity on a horizontal circular path with radius 6 meters. So meaning here we have a circular paths. This is a circular path of motion. And the radius of the motion, circular path here is given by the equation is 6 meter. Okay, this is R. If the frequency of the object is 0.2 hertz, at 0.2, if the frequency is equal to 0.2 hertz, so meaning here, how you can define, how you can describe 0.2 hertz, meaning this is equal to 1 over t. This is per second. Okay, per second. Maksudnya kat sini kalau kamu jelaskan mengenai frekuensi, how many complete circle in 1 second. So this is frequency is 0.2 hertz. Right? So centripetal. So the question asks you what is the value of the centripetal acceleration. So AC. So as you know the equation for the AC, so you can use a V square divided by R, or you can relate to the, because V, velocity, so this is the speed of the object, V tangent, you can relate to the or equation V also, we have a radius time omega, right? And yeah, omega, okay, you can use the 2 pi divided by the period T. So maksudnya kat sini berbagai rumus ataupun perkataan yang boleh kamu gunakan. So ikutlah kesesuaian. So how to calculate the AC here? So first, if you use the equation omega, because AC is equal to V square divided by R. So here V square, because V is equal to R omega, radius time angular velocity. So this is R square omega square divided by R. So V square sini so gantikan, and this is R. So here we have R here. So here we have R omega square. The radius given is a 6 meter. And what is the omega? So omega you can use the equation here, or you can use, because the equation gives you the value of the hertz frequency. So omega is equal to 2 pi f. So the omega here 2 pi, the frequency is 0.02 hertz. So you can find the value of the omega. So you can put the value of the omega in the equation here, and the radius is equal to 6 meter. So you can find the value of centripetal acceleration. So you can use the calculator and the final answer. The final answer is equal to C, 9.48. So you can use your own calculator to calculate the centripetal acceleration. So this is the process or the step how you can find the answer or the solution for the question number 5. Okay, class. So we continue to the subjective question. Right, start with the question number 1. Right, it's question number 1 here. Okay. New. Right. Question number 1. Okay. Subjective question, question number 1. Number 1A. Explain briefly why a particle moving with a constant speed v in the circular paths with a radius r experience acceleration a. Okay. So again, if you relate to this is the objective question yang kita bincang awal tadi, dan this is the question number 1. Ask you about the speed, the velocity of system if you relate to the circular motion. So here, this is the circular parts. Right? So how you can relate between the constant speed and radius r, and how you can relate to the acceleration a. So the first we have a circular path. So this is the path of the motion. Yes, arah gerakan satu putaran. And the first you have a tangential velocity. So let's say this is a tangential velocity. Tangential velocity is just always 90 degree. Just, okay, saya gambar raja saya tak berapa betul saya ubah balik. Okay. Yeah. Cantik sikit. So we have a circular path here. And next we have this is the center and this is the radius. So if you have the tangential velocity, tangential is always 90 degree to the radius r. So let's say this is a v. So here we have a v direction to the downward, and this is a radius r. So here we have direction of the v here to the right. So this is a 90 degree, 90 degree, 90 degree here. Direction of the tangential velocity is to upward v, and this is angle 90 degree. So now if you look at the value of the speed, the speed for the speed v1, v2, v3, and v4, we have the same magnitude. Okay, let's say we have 3 meter per second. So now the object moving with the constant speed 3 meter per second, not the constant velocity. Why not constant velocity? Because the direction of the v is always changed. So this is upward, this is to the left, this is to downward, this is to the right. So meaning the item, the object here moving with the continue change velocity. So the change velocity produce centripetal acceleration A. So where is the direction of the centripetal acceleration? So centripetal acceleration AC is always direction to the center of the circular part. And if you have the AC, you have also centripetal force and direction the same with the AC. So direction of the AC is equal to direction of the FC, or you can relate FMAC for the circular motion. So FC is referred to the centripetal force, AC centripetal acceleration, and the M is a mass of the object. Mass of the object is constant. Right. So this is how you can relate between the velocity or the speed, radius r, acceleration or centripetal acceleration, how you can relate to the centripetal force. Okay, number 2, sketch a diagram. Show the direction of the V and A. Ya, saya dah terangkan tadi ya. The direction of the velocity is always tangential to the radius r, but the change of the velocity produce centripetal acceleration A. And this is answer number A1 and the A2 question number 1. Continue to the question number B. Okay, write an expression for the FC. FC here is a centripetal force, right? Centripetal force. Centripetal force FC in the term of mass, velocity, and the radius r. So as you know, the equation for the centripetal force is a mass times speed squared or velocity squared divided by radius r. Right? This is number 1, and number 2. If an object of the mass 3.5 kilogram is traveling in the circular path with a radius r 3.14 meter at the speed 3.46 meter per second, what will be the centripetal force? So if you draw the diagram situation given by the question, so the first objects are moving with the, let's say the speed of the V, tangential velocity is equal to 3.46 meter per second, and the radius of the circular path is r is equal to 3.14 meter, and mass of the object here, the mass is equal to 3.5 kilogram. So now what is the centripetal force? So the information mass is given 3.5. 3.5. The velocity here is 3.46, but here is a square, so make sure. And the radius up is 3.14. The straightforward, we can use the calculator to calculate the centripetal force. I think this is the correct answer given by the question, 13.34 Newton, because this is a force. Centripetal force unit is a Newton. This is answer number 1B. Continue to the question number 2. Question number 2. So what is the situation given by the question number 2 here? 1,500 kilogram car is moving on the flat horizontal curve. So this is a car, sebuah kereta ni sedang bergerak dalam satu curve road, satu selekor. As shown figure, if the radius of the curve, so let's say ini adalah curve, so meaning here if you draw the complete circle here, the radius here from the center here is equal to 3, the radius of the curve here 35 meter. So this is the radius of the circular part. The coefficient of static friction between tire and the dry road. So meaning here, kereta ni dia bergerak. So meaning here the tire and the surface of the road touch each other. Touch each other meaning, okay, katalah saya lukis kat sini, ini katalah tayar kan. So we have the two surface here. The two surface here is refer to the surface of the tire and the surface of the road. And the friction between the two face here is given by the value of the friction nu is equal to 0.5. So number A, calculate the maximum speed the car can have and still make turn successfully. So meaning here, the car continue moving on the flat horizontal curve, still make turn successful. So meaning maksudnya dia boleh melakukan pergerakan di selekor ini tanpa ada berlaku mungkin tergelincir keluar ataupun ke dalam. Okay. So dalam kes ini, kalau kamu nak selesaikan dalam kes ini, so make sure, okay, the object moving in the circular part, ataupun walaupun dia melalui satu selekor, sebenarnya kalau kita complete kat sini satu putaran lengkap, walaupun dia cuma melalui satu selekor yang pendek, tapi kalau kita complete sini, dia seperti satu putaran lengkap. So meaning we have a radius r dan dia bergerak dalam satu putaran. So dia ada centripetal acceleration dan dia ada centripetal force. And the direction of the acceleration A, C and FC to always center to the circular part. Okay, arahnya sentiasa ke dalam. So friction arah ke mana? Untuk kalau kamu cuma ada FC sahaja ya. Okay. Saya lukis lagi yang besar sikit okay, besar sikit supaya nampak lebih jelas kat sini, sorry. Okay, sorry. Okay, saya padam dulu yang ini. Alright. Okay, saya kalau saya lengkapkan curve ini, so we have a complete circular part. So we have a radius r. So meaning here, if you have the radius r, you have a centripetal acceleration. And also you have the centripetal force, Fc. But if the car moving, okay, moving in the circular part, so meaning we have a net force Fc. Dia akan ada daya bersih centripetal ke center, okay, ke pusat, ke dalam. So kalau daya bersih, kereta ini akan bergerak ke dalam. Jadi yang berlaku sekarang ini, geseran di antara tayar kereta dengan permukaan jalan, the friction between the surface of tire and the surface of the road, the direction of the friction is a direction to the let's say this is friction, the small f here, sorry, saya gunakan simbol dia. Yang biasa kalau friction kita pakai f ya, friction force. Sini we have static friction, so we have a f subscript s. So meaning here, to make the car successful, okay, continue moving in the curved track or curved road here. So the force, centripetal force and the friction, you can relate to the centripetal force of the car is equal to friction force, right? Friction force. So centripetal force equation, kita tahu mv square divided by r. So the direction of the FC here to the center, to the, let's say to the left, but direction to the friction force to the right. But because of FC is equal to Fs, so meaning kereta ni tidak bergerak keluar, tergelincir keluar ataupun tergelincir ke dalam. So meaning dia continue moving, okay, on the curved road tanpa ada terbabah dan sebagainya. So dia kata successful, okay, moving in the curved road when Fc is equal to Fs. So what is the Fs and friction force? So this is chapter 2 or chapter 3, chapter 4. Friction force is a new time normal force, right? New time normal force. So now if you use the equation mv square divided by r, new and n normal force is always mass of the, this is on new, this is object, and this is the weak force, and the upward force is a normal force, but the object is not moving upward downward, meaning n is equal to the value, and the value is equal to mass times g. So here we have a n here is equal to mg. So the question asks you to calculate, I think the question here, so okay, the question asks you to calculate the maximum speed of the car, the maximum speed. So meaning here the maximum speed, we have a mass. This is a cancel. Arc radius is given by the question is 35 meter radius, and mu is given by the equation 0.5, and g is constant 9.81 meter per second. So you can find the value of the v here. Yeah, so you can use the value v, or you can relate to the, you can, if I refer to the answer given by the question, the v here is here 30.102 meter per second. So I think this is a correct answer. You can use your own calculator. Nanti boleh rujuk dekat jawapan ni. Tapi the equation here, ingat ya, seperti yang saya nyatakan kat sini tadi. Okay, kita balik kat sini rajah ni tadi. Untuk memastikan kereta ni boleh bergerak melalui selekoh ini kalau friction dia tu dia bagi sini kena coefficient 0.5, so the velocity 13.102 meter per second, maksudnya cukup untuk the v here 13.102 meter per second is enough for car move horizontal curve road, okay, berjaya melalui selekoh tanpa apa-apa berlaku tergelincir ataupun terbabas keluar ataupun ke dalam. Right? Okay, so continue to the question number B. The same situation, but the same car and the same curve road, but number B give the situation is, suppose the car travel on this curve a wet day, begin to skid when the speed is reached 8 meter per second. So now here we have the change of the velocity. So velocity here is 8 meter per second. And calculate coefficient of static friction US in this case. So meaning here, the friction between the two surface, is changed now because of the type of surface. Permukaan sini sudah mungkin basah, mungkin hujan dan sebagainya, tapi pada kelajuan 8 meter per second. So sama juga kat sini kalau kita tengok dari segi pengiraan ataupun perkaitan untuk kereta tu bergerak supaya dia tidak tergelincir ataupun tidak terbabas keluar ataupun masuk ke dalam. Jadi apa yang perlu kita kaitkan kat sini sama juga the centripetal force Fc direction to the upward, direction to the center. Ataupun kat sini saya buat so direction to the center Fc or to the left. This is the car, and we have a friction force or static friction. So Fc is equal to Fs, and Fc here is a mv square divided by r is equal to nu Fs is nu times n normal force. So now mass tak berubah So now saya pecahkan sini nu is equal to mg, so we can cancel the m here, and the r is constant seperti yang dibagi awal tadi boleh rujuk dekat soalan, and the g is constant. G is constant 9.81. So now the velocity is 8 meter per second. So now you can find the value of the nu. The nu here, you can use the answer given, you can refer to the 0.186. Okay, ini kamu boleh kira nantilah untuk nilai nu. Ini saya bagi cadangan di mana kamu boleh dapatkan penyelesaian untuk question number B. Okay class, we continue to the question number 3. Okay, question number 3. Okay, question number 3. A person is staying at in a country situated at the equator. So, katalah kita ni permukaan bumi permukaan bumi. So, ini katalah equator kita. So, katalah satu jasad the objects, kita tahu apabila jasad berada di permukaan bumi, dia akan berputar satu putaran lengkap macam kita kalau satu hari itu daripada pagi, petang, malam dan seterusnya sampai ke pagi balik. So this is one complete oscillation. Mengambil masa selama the period of one complete oscillation circle is T is 24 hours. 24 hours. This is referred to you can the period of T, time taken. Complete circle daripada pagi, petang, malam dan kembali kepada pagi. Right? So, okay, this is radius of the earth. So meaning the radius here, the radius from the surface of the earth to the center of the earth is 6,400 kilometer. So this is the value of the radius r. So the question asks you to calculate the angular velocity. So angular velocity here, or omega, is equal to, okay, equation, ini kita dah bincang tadi 2 pi divided by t. This is a distance. Because to calculate the angular velocity, this is a distance, jarak bagi dengan masa. Okay, omega is equal to the distance here. The distance here for the angular velocity or circular motion is referred to the theta. Theta is a complete circle. Complete circle, satu putaran lengkap. Complete circle is referred to the 2 pi or 360, 360 darjah. And the time taken, so here we have a 2 pi. Theta is equal to 2 pi. And the period of T, as I said, one complete oscillation is equal to 24 hours. But the SI unit, because we have a second, so meaning here, you must use a 24 hour, okay, 24 hours, okay. Dan kita tahu dalam jam, satu jam kita ada 60 minit. 1 minute we have a 60 second. So now we have this is a 2 pi. So now the omega here is equal to, so you can use the calculator, is 7.27 times 10 power of minus 5, because the unit for the 2 pi here is radian. And this is a second time or period t, so unit for the omega is a radian per second. So we have 7.27 exponent minus 5. Alright. Okay, so continue to the number B. Number B asks you to calculate the speed of the person as the earth rotates. So kita tahu jikalau macam kita sekarang ni berada di bumi, sebenarnya kita sedang berpusing. Okay, sedang berpusing. So how you can calculate the speed? The speed. So we have the equation. You can relate speed, and the omega is V is equal to R omega. And the value of the radius, this is radius of the earth, is 6,400. This is kilometer. So convert to the meter is times 10 power of 3. And the omega, you have already calculate answer number A, 7.27 exponent minus 5 radian per second. So you can find the value of the speed here. Speed here is a 465 meter per second. So this is the speed of the person as the Earth rotates. Right? So number C, does the person realize he is moving with the speed calculated in B? Give your answer. So macam kalau kita berada sekarang ni, kita berada di bumi. Tapi kalau ikut soalan ini, the question number B, dia kata kalau jasad itu berada di bumi, sebenarnya dia sedang berpusing. Okay, 465 meter per second. Tapi why? Okay, mengapa kalau kita tidak merasa kita sedang bergerak? Because of apa? Bumi berpusing sama dengan kita bergerak, berpusing. Contohnya apa? Kalau kamu naik kapal terbang, bila kamu berada dalam kapal terbang, okay, kamu dapati kamu tak bergerak. Sebenarnya daripada relatif kepada orang tengok, sebenarnya kamu sedang bergerak dengan hal laju kapal terbang tersebut. That's why kita berada di kapal terbang, kita tidak merasa bahawa kita sedang bergerak. So the same process, why the person realize is moving with the speed of a calculated. Okay, the situation here in B, because of the person does not know he is moving with the speed because both of the person and the Earth rotate with the same angular velocity, right? So maksudnya kita tidak nampak. Tapi kalau kita contohnya kawan kamu berada di bulan, kamu berada di bumi, so kita nampaklah kamu sedang berpusing. Okay, sekarang ni kita semua berada di bumi, so kita tidak benda bergerak, tapi kita tidak perasa benda tu sedang berpusing. So this is answer for the number 3C, right? Continue to the question number 4. So number 4, we have a ball of mass move with a constant velocity v, constant velocity v in horizontal circular path. So if you look at the figure 2, so we have the object and the ball with the mass m and constant velocity v, moving with a constant velocity, berpusing dengan constant velocity v, and radius r. So the radius, this is r, and the ball attached to the string, disambung dengan string of the length is 24 and make conical pendulum. Okay, dia panggil, bila kita tegangkan dia keluar ke sana, lepas tu kita pusingkan dia macam ni conical pendulum. This is a pendulum system or conical pendulum system. So this is a situation given by the question, and the question asks you, sketch the free body diagram. So now, free body diagram here, because we have the object M, so meaning we have the mass, and the mass we have the weight force. Weight force already direction to the downward, and the ball connected to the string, connected to the string. That's why the direction of the tension string T is upward. So if you draw the free body diagram, you have only two forces, the tension of the string T direction to the upward, and we have the weight force. Weight force is always direction to the downward. So this is the two force if you draw the free body diagram. Alright, so continue to the number B. If the theta is 30 degree, calculate the radius. The first is calculate the radius and calculate the velocity, right? So now, how to calculate the radius? So now we can use the diagram here. Alright. So first is this is 24 cm. So this is, you can draw the diagram here. So this is 90 degree. So this is R. Okay. So this is 24 is the length of the string. Length of the string. So number one asks you to calculate what is the radius R. So you can use the triangle here. So you can use let's say this is theta. Theta is given by, theta is a 30 degree, right? 30 degree. So if you the triangle here, so you can use the, let's say you have the sine theta, sine theta. Sine theta is the opposite divided by hypotenuse. So sine theta, sine theta, sine 30 is equal to opposite is a radius R, okay, divided by hypotenuse is L. So now the L here and the L here is equal to 24 cm, right? So you can find the radius R. So you can use the calculator here, and the R is equal to 12 centimeter. Okay, class? Okay, so next question is calculate the speed or the velocity here. So to calculate the speed or the velocity here, because the object or pendulum start moving in circular motion. So if the pendulum moving at a circular motion, so meaning we have a centripetal force direction to the center of the circle here. So now you can use the same triangle here. Tapi kalau kita nak lukis kat sini ya, saya lukis kat sini. The triangle here, tadi kita consider length 24 cm. So now here is the question asks you to calculate the V. So you can consider the tension because we have according to the free body diagram, we have the weight force mg, and we have the tension of the string. So now here you can to calculate the V here, you can start from the centripetal force. If the object moving in the circular parts, so we have a centripetal force direction to the center. So Fc here is equal to mv squared divided by r, centripetal force of the pendulum, right? And how you can relate Fc and the tension of the string. So this is direction of the Fc, sorry, the center to the center, meaning to the right. This is the C, and also we have the T. So T is force, Fc is always also force. So how you can relate T and Fc? Okay, so we have a triangle here. So the triangle here you can use a T sine theta. T sine theta here, T resolve to the, sorry, the T here, if you resolve to the Fc here, or we can use a T sine theta, this is opposite, is equal to Fc. Fc kat sini sebenarnya adalah kita boleh resolve T ni ke arah, atau kalau kita guna dulu yang cikgu awal dudukan force kan, this is arah X. Okay, T sine theta is equal to Fc, and Fc is equal to mv square divided by r, right? So this is Fc. So satu lagi kalau kita tengok kat sini, T ni juga kita beri solve pada arah Y. Okay, arah Y is a adjacent. So this is T cos theta. Kita guna segitiga ni, T cos theta, or T cos theta, tension resolve to the Y axis direction to the upward. So we have the upward force only, we have a vertical force, weight force, but direction weight force to downward. But tapi pendulum ni tidak bergerak ke atas, tidak bergerak ke bawah, meaning daya ke atas, T cos theta is equal to daya ke bawah, this is equal to weight force, this is equal to mg. So now here we have the two equation. Let's say this is equation number 1, and this is equation number 2. You can relate between T sine theta is equal to mv square divided by r. Also we have T cos theta is equal to mg. So kalau kita bagi dua bersama ni, so meaning here we can cancel here, sine divided by cos is a tangent theta. Okay, tangent theta. This is theta is a 30, is given by the equation is 30. And the mass can cancel, and V here, memang kita nak cari V kan, and the G is a, V square divided by, okay, G so G is equal to 9.81. So meaning you can find the value of the V here. So if you use the calculator, the value of the V is equal to 0.8244 meter per second. So the answer, the speed of the pendulum, when the pendulum start moving with a circular motion or circular paths, right? Okay, so continue to the next question is number C, 5C. The 5C here, the 5C is if the velocity is more than 30, what you can deduce about the velocity. So if you relate to the velocity, velocity and equation, kalau tapi dah padam tadi, sebenarnya velocity kalau kita tengok tadi, you can relate to the, you can relate between velocity and the theta here, or you can use a tangent theta here, right? Tangent theta. So meaning here, if the theta is increased, so actually the V is also increase. Maksudnya kat sini, kalau rajah ni, kalau kita logiknya, kalau kamu besarkan lagi dia punya, setelah kamu tarik kat sini kan, so the angle is greater than initial angle theta. This is theta 2. Kamu tarik lagi besar theta. This is theta 1. So if the theta 2 is greater than theta 1, so meaning logiknya bola ini akan bergerak dengan lebih. So V is also increase for the theta 2, or the V2 is greater than V1. Right? Okay, so continue to the numbers. Okay, number 5. Okay, number 5 here. Right, number 5. And number 5. 5 here. Right. Okay, continue to the question number 5. Okay. Asian, so if you look at the figure 3, so 1 point, this is the mass of the ball is 1.34, right? 1.34. Okay. Okay. Connected by means of two massless string is rotated to the rod. The string tied on the rod stretch. The tension of the string is 35 Newton. Okay. So sekarang ni, okay, kamu ada satu jasad, kamu ikat dengan dua tali two string to the upward force string because tension to the force, and this is tension of the string. You see, this is T1 and it is T2, and the upper string is 35 Newton. 35 Newton. Okay, number 1, draw the free body diagram. So free body diagram. So how you can draw the free body diagram? Okay, the free body diagram here, right? Because how many force acts on the system? So we have the two strings. So meaning we have the force 1, force 2, and also we have a weight force here because we have the mass. Direction to weight force is always downward. So meaning if you draw the free body diagram, we have a tension of the T1 and the tension of the T2 direction, and T2 is downward, and we have also straight to the downward, we have a weight force. So we have a 3 force, and T1, T2, and the weight force, W. Okay. Numbers B. Okay, calculate tension. Okay, saya kecilkan sedikit supaya nampak jelas sikit. Calculate tension in the lower string. So what is the, let's say this is T2, because the T1 given by the question is 35 Newton. So sekali lagi kat sini because katalah jasad ini dia berpusing ke, tidak berpusing ke, tapi sama tadi. So for the free body diagram, we have T1, we have the T2, and we have the weight force W. So we have the 3 force here. So seperti biasa, you can resolve to the Y or you can resolve to the X axis. Yeah, right? So now the question asks you to calculate the T2 here. So to calculate the T2, because this is the static, dia tidak bergerak ke atas, tidak bergerak ke bawah. So meaning here, if you refer to the vertical force, daya ke atas ataupun daya ke bawah. So you can use a triangle here. So this is 90 degree. So this is a tension of the string as given is 1.7. Oh, di panjang kita dia bagi tahu this is 1.7, and this is half 1.7 also 1.7 meter. So meaning kat sini kamu boleh cari theta kat sini kan, theta kat sini, because we have the two item here, the length here and the length here, right? Okay, so if you calculate the theta, so you can find the value of the theta right here. Okay, use the triangle here. So we have a, so let's say you have a tangent theta, right? Sorry, we have a, sorry, use because there is the hypotenuse. Let's say we have a cos theta, okay? Cos theta is equal to, this is a radius, let's say, radius divided by, okay, hypotenuse. This is a hypotenuse. Hypotenuse is a 1.70 meter. So now you can find the value of the, okay, so sorry, because trying to find the theta. So you can use this 17, okay. So 17 here, so you can find this is half. So panjang sini dah boleh bagi tahu kan. So you can use tangent theta, Tangent theta is equal to, this is 1.7 divided by 2, and the adjacent is a sorry, no. Okay, suggestion here, say adjacent is R. So now you can find the value of the R here, right? Was connected, okay. Tension. Kalau kita nak cari R kat situ, macam mana kita nak cari R? So T sin theta, okay. Katakanlah saya, kita buat macam ni dulu. This is ball screen rotate, calculate. So this is 1.7 meter. So ini katalah theta, kita boleh sini. Okay, this is kalau kita nak cari panjang kat sini, this is 1.7 divided by 2. So baru kita boleh cari dia punya nilai theta kat sini kan. So you can use a sin theta is equal to 1.7 divided by 2 divided by 1.7. So you can use a calculator here, theta. So it's half, so theta is equal to 30. So now 30 degrees. So here is a 30 degree here. So next you consider the tension. So sekarang ni kita dah consider tension, because this is T, T is given by the question is 35. So now 35 Newton here, if you resolve to the y-axis, ataupun kita resolve kat sini, daya ke atas, this is T sin theta, right? Sin theta. And we have the downward force, W, weight force is equal to mg, right? So now, so upward force is equal to downward force because the object is not moving downward and upward. So you can use a T sin theta, right? Minus T sin theta minus, this is also 30 degree. So we have another T here. This is T. This is for the T1. And this is T2. So resolve to the T here. This is T2 direction downward. Is same direction. So meaning here, we have a upward force T sin theta. Downward force we have two opposite, 2 sin theta. T2 sin theta. This is also direction, same direction to the weak force. So minus T2 sin theta minus weak force is equal to 0 because dia tidak bergerak ke atas, bergerak ke bawah. Right? So now T1 is a value given by the question is 35. And theta here is 30. Theta here is equal to 30. And the weight force here is equal to 30 times minus 9, sorry, time 9.81. So now you can find the value of the T2 here. So if you can use the calculator here, T2 is equal to 8.74 Newton. So this is T2. Right? Calculate the tension of the lower string, or T2 here is 8.74 Newton. So number C, calculate the net force on the ball. Okay, net force. So meaning here, if the object rotate, rotating rod, rotate meaning we have a centripetal force. We have the centripetal force or FC here. So FC here is a net force. FC here is equal to net force, daya bersih yang menyebabkan dia berpusing. Tetapi kalau kita tengok kat sini, because we have a tension T1 direction upward and we have the T2 direction downward and we have also W weight force NG direction downward. So meaning the value of the net force here, FC here, you must consider influenced by the three force here. Right? So, or you can use the tension of the T2 because T2, if you resolve to the x-axis or resolve to the horizontal line here, T2, and the T1 is same direction to the centripetal force FC. So meaning here, combination this is T1, T1 and the T2, if you resolve to the horizontal line here, meaning T2 cos theta and the T1 cos theta, or you can use the equation T1 cos theta plus T2 cos theta is equal to menjumbang kepada net force ataupun FC, ataupun FC is a mv square divided by r. Okay, class? So now, net force of the object mass here is equal to T cos theta plus T1 cos theta plus T2 cos theta. So this is equal to, nilai sudah bagi, this is 35, T2 is a 8.74. So you can find the value of the net force is equal to F net. F net is equal to 37.88 Newton. Okay, this is number C. Number D, the speed of the ball. Because the object start moving, rotate the rod. So meaning we have a centripetal force, Fc is equal to 37.88, but Fc is equal to mv square divided by r, right? So now you can find the value of the speed of the ball here, okay, v here, because mass is given by the question 1.34, and the radius you can calculate. Kita dah kira awal tadi, r kat sini kan, radius tadi kita dah kira tadi awal, and you can find the value of the v. So v here, if you look at the answer given is 6.45. So nanti boleh kamu kira sendirilah, kira yang number D. Okay, class, continue to the number 6, right? Number 6, so we have another 4 question, right? Nanti dah mencecah 1 jam, sekejap lagi kita boleh habis sepadan. Class. Okay. Okay, question number 6. Define centripetal force. Saya rasa yang ni boleh rujuk balik yang kita dah bincang tadi centripetal force. Okay, saya nak terus pergi kepada number 6B. Alright. Okay, an object of mass is attached to the strings of length L. Right, so yang ni dia tak bagi rajah. So, okay, the object is moving with the constant speed v in a vertical circle. The maximum tension of the string is T max and the g acceleration due to the gravity. Sketch, dia tak bagi gambar rajah, but you must draw the diagram to illustrate the force and object when it is at the top and at the bottom of the circle. Okay, So macam mana? So dia secara vertical lah. So let's say this is a motion of the object, right? So this is at the top, right? So we have the string, and the second part is referred to the object at the bottom, okay, at the bottom. So also we have the string, but the tension of the string, tension of the string is always to the center, and tension of the string here is referred to the, okay, perkaitan force, dia bukan centripetal force, this tension, tali, tension of the string, right? So, and the object have the mass. If the object have the mass, meaning also we have a weight force, right? Or is equal to mass times g. And this, when the at the bottom, W is a direction to the downward, right? So, meaning here at the top, at the top here we have a direction of the tension is the downward. Direction of the weight force is also downward. That's why this is weight force and this is tension, right? And at the lower, at the bottom, so the direction of the string is upward because ketegangan tali ke atas, dia pusing, Tapi weight force ke, this is T, upward, but the weight force direction to the downward. Okay, so this is how you can relate between the tension of the string and the weight force if the object at the top and at the bottom. Okay, number 2. Write an expression for the centripetal force X and object. Yeah, because this is a circular motion. So meaning here we have a FC, centripetal force. As you know, the centripetal force equation is a mv squared divided by r. Mass, velocity, and the radius r. Okay. If the string break with the position wheel is like this occur. Okay, so dalam kes ini, kalau kamu tengok kat sini, tension of the string, kalau ikut rajah yang saya lukis kat sini, dia maksimum, ketegangan maksimum, the maximum tension of the string when the object at the bottom, because weight force ditarik ke bawah akan meregangkan tension itu ke atas. So this is T maximum. Jadi risiko untuk putus tali itu pada masa ni, kerana pada masa ni logiknya masa dekat atas tu tension ataupun tali tu dia agak kendor berbanding dengan yang di bawah, right? Okay, derive expression for the T maximum. So T maximum here at the bottom. So at the bottom here, so we have a direction of the string, tension F upward and weight force downward. So meaning here, the T here, T maximum, right, is equal to mg. But the string ataupun tali ini tidak putus. This is not the break string. Jadi maksudnya kat sini, daya ke atas sama dengan daya ke bawah. Okay. Dan bila kita tolak T maximum minus mg, daya ke atas tolak daya ke bawah, dia akan menghasilkan satu daya bersih, iaitu dia merujuk kepada centripetal force, right? Centripetal force yang kita kenali sebagai Fc is equal to mv squared divided by r. So now to calculate the T max is equal to Fc plus mg. Okay, so number 4, if the mass 50, L 60, right, and the V 10 meter per second, calculate the T maximum. So you can use the equation here because right here. Okay, saya lukis tak boleh tulis dekat sini. T max is equal to Fc here plus mg, weight force. Fc is equal to mv squared divided by r plus mg. So now the mass here And the mass here is equal to the mass. Oh, okay, sorry, 50 But this is a 50 gram, so use a convert to the kilogram. And the V here is 10, given by the equation, 10 meter per second. And the G is 9.81, and the radius R is 60 cm. So this is exponent minus 2 lah, per meter. So you can find the value of the T maximum. So if you calculate the T maximum here, so the T maximum, if you refer to the answer given is 8.824. Saya rasa betul lah jawapan ini. Nanti kamu kira lah. Okay, class. Complete number 6. So we go continue to the number, okay, question number 7. Okay, number 7 is the Ferris wheel. Ferris wheel. Okay, so Ferris wheel here. Biasa kamu tahu kan apa itu Ferris wheel, yang biasa kalau ada fun fair tu kita naik Ferris wheel kan. So now for question number 7. A Ferris wheel diameter 8 meter and rotate rate 4 RPM. So the first RPM mungkin saya rasa kalau yang belum jumpa tu kan, RPM. So RPM. RPM is referred to the stand for the R is a revolution. Revolution. And this is minute. Okay, putaran per minute. Maksudnya kat sini 4 RPM meaning 4 RPM meaning 4 revolution per minute. Maksudnya dalam 1 minit dia membuat 4 pusingan lengkap. This is 4 RPM. So, okay, so Ferris wheel dia akan berputar ya. Dia akan macam berputar. Okay, ini dia punya R dia akan berputar macam biasa. This is circular part. Dia punya rotate with the 4 RPM. Rotate with the 4 RPM, this is a revolution per minute. V or angular velocity is 4 RPM, 4 revolution per minute. Okay, rotate. So now, acceleration of the rider. So berapakah dia punya rider ni, dia punya acceleration. So to calculate the acceleration, so we have the acceleration is equal to V square divided by R. So now how to calculate the V? So to calculate the V here, so the V here you can use the V is equal to R omega. So radius here is 80 meter. So R is the omega. Omega is a refer to the 4 RPM. But you must use the change to the SI unit or used for the revolution 4 RPM. So one revolution is equal to 2 pi. Okay, per minute convert to the second is 1 minute. 1 minute is equal to 60 seconds. So now here is just the omega here 4 RPM. 4 RPM here is equal to okay, if you use the equation here, V is equal to R omega, and R is equal to 18, and omega is equal to 4 RPM, convert to the radian, convert to the second, here is equal to 4 revolution, 1 revolution is equal to 2 pi, and divided by 60, 1 minute, 60 seconds. So you can find the value of the V here. Sorry, this is not the V. This is omega. Sorry, this is equal to omega. Okay, omega. Right? How you can convert 4 RPM? You convert 4 RPM convert to the radian per second. So this is the process here. So the omega here is equal to 0.419 radian per second. So to calculate the acceleration here, so first you boleh guna persamaan ni, ataupun acceleration juga boleh pakai omega square R. Okay, because V is equal to R omega. So now, if you use the equation, omega here, this is omega is equal to 0.419, and the radius here is 18. So you can find the value of the acceleration. Okay, I think this is correct answer, 1.5 meter per second lah. Nanti bukan boleh kira Okay, so next question number 7B 7B. So the 7B here, the magnitude and direction. The magnitude and direction of the force with the seat exert 40 kg at, okay, so sekarang ni kalau kita tengok dalam soalan sini, dia akan bagi, okay, sorry, ada dua situasi. At the lowest point, at the highest point. Okay, so at the lowest point, okay, saya padam juga supaya kita ada ruang untuk sini. Okay, at the lowest point here, Ferris wheel Ferris wheel berpusing. At the lowest point here, okay, so bila kita berdiri kat sini, so maksudnya apa? Kita ada normal force ya, biasa kerana kita berdiri kat sini, so kita ada normal force ke atas, and we have a weak force ke bawah. This is mg, right? And dia berpusing. So meaning here dia akan ada satu lagi daya yang merujuk kepada centripetal force Fc. So how many force here? We have only N and W, but rotate you produce net force Fc. So Fc here is equal to, okay, dia tidak bergerak ke atas, tidak bergerak ke bawah, tapi ada net force ke dalam. So normal force tolak dengan downward force W is equal to centripetal force, right? So now here we have a F is equal to, Fc is equal to mass times AC. So now to the question asks you the value of the exerted force. So N. So N is equal to MAC plus W, or W is equal to mg. And now you can use, because M given by the equation, boleh masukkan nilai, G is a constant 9.81, and acceleration is the answer for the first question. Okay, yang soalan pertama tadi kita kira tadi apa tadi? 1.58 meter per second square tadi kan? So last sekali kau boleh cari nilai M. So N given is 5455.6 Newton. So what happened to at the highest point? Pada ketika ni macam mana? Still lagi dia akan berada berdiri kat sini kan? So meaning here apa? Sama juga kamu akan ada, we have the two force here. The first force is a weak force, W, and we have a normal force upward, N. But this motion we have a centripetal force direction to the downward. So if you compare to the at the lowest point here, dia terbalik kan? Dua keadaan ini. So bersama kat sini, daya ke atas and daya ke bawah, because net force dia Fc ke bawah, so meaning centripetal force or Fc is produced by the weak force minus normal force. So this is equal to MAC. Sama juga yang dekat sini. Jadi kita nak kira dia punya nilai N. So dapatkan nilai weak force mg, katikan M, acceleration daripada answer yang pertama tadi 1.58, and you can find the value of the normal force. This is 329.2 Newton. Okay class, kita kira sendiri ya. Okay, so continue to the next question. Okay, number 8. Okay, number 8. Okay. Okay, question number 8. A roller coaster has a car mass 1,200 kilogram and fully loaded with the passenger. As the car passes over to the top, the circular hill radius is 18 meter. Its speed not change, but the magnitude and direction of the force on the tracks the car to hill if the car is speed 11 and 14. Oh, ada soalan lagi kat situ ya. Okay. What are the magnitude and direction? At the top, if the speed 11 and 14. Oh, okay. Maksudnya kat sini dia bergerak okay, dalam circular path juga kat sini kan. So maksudnya kat sini dia nak dapatkan dia punya first itu roller coaster. Okay, setelah roller coaster tu kan, dasar katalah ni bergerak kan. Sama juga kat sini kan. Roller coaster contohnya kan, sini saya bagi kan. So pergerakan ini katalah dia sedang bergerak ke sini kan, roller coaster tu, ni tayar dia kan. So, sama juga dia macam curve surface ini kan. So sama juga dia akan ada radius up contohnya kan. Okay. Radius of the hill tu katalah this is 18 meter. Right. So now magnitude and direction of the force of the track. So now here pada keadaan yang macam ni sama macam kes yang soalan yang tadi so dia ada weak force W ke bawah and dia ada normal force ke atas. Tapi dia macam mana? Okay. Kalau kita tengok kat sini, sorry, this is roller coaster. Saya rasa kalau gambar rajah kita ni dia bukan macam ni kan. Saya rasa dia salah ni. Tapi sini untuk roller coaster. Okay, kita balik sorry. Alright. Okay, katalah dia sedang, saya lukis ni sikit Okay, melukis satu. Ni katalah roller coaster. Okay. Dia ada keadaan terbalik macam ni kan, dia tayar dia. Okay, dalam keadaan macam tu, dia sedang berpusing. Atas ni roller coaster dah turun ke bawah balik macam tu. Okay, saya rasa itu situasi dia ya. Tapi pada masa ni dia tidak jatuh ke bawah. So mengapa dia tak jatuh? Tapi kita consider the force. So the force we have a weak force ke bawah. And because the tire and the surface of the track of roller coaster here touch each other and we have a normal force also direction to the downward. And this is circular motion. So we have a centripetal force Fc. So to produce Fc here is come from the normal force plus weak force. So here we have a the direction of the force of the track. So meaning here nilai ni yang kita nak cari N. So the N here is equal to centripetal force minus weak force. So the weak force is equal to mg and the centripetal force is equal to mv square divided by r. So to calculate the value of the N, you can use the value mass is given by the question is 1,200 kilogram. This is for the M, right? And the G is constant 9.81. And the speed is, the first A is 11 meter per second, right? And the radius R is 18, right? So you can find the value of the N here. So if you calculate the N is equal to, the value here is negative 3705.33 Newton. So negatif dia merujuk kepada apa? Dalam kes ini, kereta ini akan jatuh ke bawah. Right? Jatuh ke bawah. Right? Okay. So kita pergi tengok pada situasi kedua. Pada situasi kedua, kalau kita tengok the speed, the first speed is 11 meter per second. And the second speed increase, the car moving with the increased speed is 14 meter per second. So if you have the value of the V here, 14, 14. So if you the calculator, this is N1, and the second N for the second speed, 14. So the N or N2, if you the calculation, you can find the calculator, calculate the N here is equal to positive 1294.67. Okay, rumus yang sama juga. Cuma V saja yang berbeza. So kita dapat nilai positif. Positif merujuk kepada apa? Kereta ni kekal akan melalui lintasan ini, tapi dia tidak jatuh ke bawah. Merujuk kepada N ni bernilai positif. Sebab itulah kalau kita tengok dalam roller coaster tu mengapa dia tak jatuh. Untuk dia naik macam ni, dia perlu ada kelajuan yang lebih laju ya. Kalau 14 dia tak jatuh ke bawah. Kalau 11 dia akan jatuh ke bawah. So itu yang number 8 Okay, so continue to the number 9. Okay, question number 9. Okay, question number 9. Okay, question number 9. A particle move in horizontal circle radius 50 cm. So this is a motion of the object in the circular path inside inverted smooth hollow hemisphere. So you can refer to the diagram here. Okay, number 1 is sketch a free body diagram. So free body diagram. Free body diagram. So first we have a weight force direction to the downward, mg. Okay, and then next, so we have a no tension, T. So we have only weight force here. Weight force mg, direction to the downward. So how many force? We have only one force here, right? Okay. So now, so the object is stuck moving. Okay, stuck moving in rotate, moving horizontal circle radius inside. Okay, so number 2, calculate the speed of the particle. The speed of the particle. So because the moving in the circular motion, so we have a FC here, centripetal force. Or you can use a mv square divided by r. This is how you can start to calculate the value of the speed of the particle. Okay, the speed of the particle. But now to calculate the v, you must know the value of the fc. So how you can find the fc here? Okay, segitiga. Kalau kat sini untuk dapatkan c tu kita kena guna segitiga kat sini. Okay, kita tengok kat sini. Okay, so let's say this is 30 cm, this is 15. So let's say this is angle theta here. Selesai kalau keluarkan dia, saya keluarkan dia punya rajah ni minus. So kita ada segitiga itu. Okay, this is here, this is 15 cm. Okay, so sekarang ni this is theta here. Okay, so this is mg or mg here, mg. So first kita boleh cari dia punya nilai apa? Dia punya sini dulu dia punya katalah panjang sini dulu, katalah L kat sini L kat sini berapa? Okay, so to calculate the value of the L here, okay, because this is the arc is this is 30 cm. So this is a radius, so this is also 30 cm. So kalau kita guna Pythagoras, kita boleh cari panjang kat sini kan. So L here is equal to square root 30 square, Pythagoras plus, because kat sini kita minus minus 15 square. So kita boleh cari L. So 30 square minus 15 square and square root 2. So the L is equal to 26 centimeter. So this is L here is 26 centimeter. Okay, so boleh cari kat situ. So terusnya dia berpusing. Kalau berpusing dia akan ada, this is Kalau segitiga yang sama juga, kalau saya lukis, okay, this is MG. So this is MG. Okay, so dia ada theta kat sini, and seterusnya dia berpusing, pusing macam tu Ini katalah center, dia akan ada FC, centripetal force ke tengah. Jadi centripetal force kita ada perkaitan FC is equal to mv square divided by R. Okay, so kalau kita tengok kat sini, centripetal force ini, kalau kita ada mg kat sini, kat sini, so maksudnya kalau kita ambil tangent theta, okay, kalau kita ambil tangent theta sini, tangent theta is equal to mg divided by force F. Jadi force kat sini, force is equal to mg tangent theta, right? And the tangent theta here, kalau ikut persamaan sini, F is equal to mg. Theta here is 26, 15. 26 divided by 15. Okay, so maksudnya kat sini apa? F kat sini kita ada mv square divided by R. So this is equal to, okay, kalau kita buat sini 15 ambil yang ni F kat sini ganti So 15 kita naik ke atas. So 15 mg divided by 26. Okay. So R is equal to, sini dia bagi 15 radius. So R here is equal to 15 tukar pada meter is -2. And the mass we can cancel here. So G is 9.81. So you can find the value of the speed. So ini mencari speed. So ganti so ini is correct answer 0.92. So this is how you can find the speed. Speed of it. Okay. Okay. So last question. Question number 10. Okay. So figure show the car travel with the speed 30 meter, sorry, kita ambil ini SI unit 13.4 meter per second on the level circular radius 15 as shown in figure. Okay, but I view figure kalau kita nampak pada atas kat sini dia melilingi satu selekor. Okay, biasa macam soalan tadi What is the minimum coefficient static friction between the tire and the road to allow the cars without sliding? Okay, maksudnya dia nak cari berapakah dia punya nilai static friction untuk case ini. Kereta ini tidak terbabas ke dalam ataupun keluar. So sama juga kalau kita tengok proses kat sini, untuk kereta ni melalui selekor, kita guna perkaitan apa tadi? Okay, kita akan guna perkaitan di antara apa? Centripetal force FC ke dalam, okay, is equal to nu. So centripetal force is equal to mv square divided by R, and the nu n is equal to mg. Okay, so now to calculate the nu here, so you can use the equation. The nu here is equal to mv square divided by R divided by mg. So we can cancel m, and this is the speed here is a 13.4, and the radius here is a 50 meter, 50, and the G is a 9.81. So you can find the nu here is 0.366. This is new. So class, that's all for today. Complex 10 question for the subjective question. So I think that's all for today. So, and the next class we continue to the chapter 7. And last Assalamualaikum dan salam sejahtera. Terima kasih. Jumpa lagi pada kelas-kelas yang akan datang. Thank you. Bye.